Good afternoon, everyone. My name is Carlos Cordero. I'm an Intel fellow, and I'm the wireless CTO of our wireless group in the client organization. So in this session, we're going to be covering the connectivity technologies that are available in Lunar Lake, all the new things that we are bringing to life in Lunar Lake. I guess the main point that I think I wanted to start with is, you can have great CPU, great GPU, great NPU on a platform, but just think about how many times you've been frustrated that you don't have internet access, right? Or the quality of your WebEx or of your Teams call, it's not good enough. So, at Intel, we spend a lot of time making sure that we also have the best connectivity technologies available in the platform, so that the experience that you expect and all the goodness that we can get out of our GPUs, NPUs, and CPUs, we actually can bring the data into the platform to make use of it. And the fact is that Lunar Lake actually brings what is best in terms of connectivity to the platform. In terms of it is the first platform to actually have integrated Wi-Fi and Bluetooth 5.4, and we also have support for LE audio. It has integrated Thunderbolt 4. We'll talk more about these things later. And in addition to the hardware, at Intel, we have a lot of software components that are unique to Intel platforms that you can only get if you're getting Intel platforms. And those are Unison, Thunderbolt Share, and Wi-Fi sensing. And I picked these three, Unison, Thunderbolt 4, and Wi-Fi sensing, because we're actually going to be showing those later today on stage, so you can get a feel for it. And I wanted to note that in Thunderbolt 4 is the one supported in Lunar Lake, but recently Intel also announced the availability of Thunderbolt 5 devices. Okay, those are discrete devices, and offers twice the speed of Thunderbolt 4. And I just wanted to highlight, how much improvement in terms of, data rate, generation over generation, we have been able to accomplish with Wi-Fi over 500 times in 20 years, and Thunderbolt 4, which is 4 times. But again, with Thunderbolt 5 coming to the future, it's going to be twice the speed of Thunderbolt 4. So what I want to show you today in this session is that not only Lunar Lake has great connectivity, but the connectivity that we are bringing Lunar Lake actually unlocks great user experiences, right? So we're going to go through many of these application user experience through demos, so that you can get an idea of how's that brought to life. And really, it's a combination of the connectivity hardware, the software, and all the platform level ingredients that we have available that really make possible that we have great experiences when it comes to playing a game online, or conference call, or whatever it is that the user is doing. Also in this presentation, you're going to be seeing this slide a few times. I'm going to use it to walk you through the various topics that we're going to cover. So we're going to start with the connectivity, everything we're doing on the wired side first, and then we're going to talk about the wireless, and then finally the software. So, but before we get to that point, we wanted to also highlight, how connectivity fits the AI PC vision, right? I mean, how do those two fit together? And then if you think about it, in every platform today, connectivity, whether wired or wireless, is the first entry point of data into the platform, and is the last exit point of data out of the platform, right? So everything goes through a connectivity pipe. Now, I think it's fair to say that connectivity sits in that very strategic place on the platform, because you can actually see everything going in and out of the platform. So what we are doing is actually making use of the fact that that is the case, to actually bring about AI PC experiences using connectivity. And I'm going to give you 3 examples of that we're actually doing this. The first one, we have a technology called ICPS. It stands for Intel Connectivity Performance Suite. It's essentially a software that, as you are using your PC, and it's looking around for access points, it's measuring the quality of the access points, looking at security, the supported bands, the connection, the backhaul connection that you have from the access points. And as you go from your office to your house, to a Starbucks, it is essentially scoring those access points and using that historical data to select the best access point for a particular traffic, for a particular application that you may be using. Okay. So essentially, that scoring, that historical data, we essentially do some learning so that whenever you go into a location, if you have seen that access point before, and we know that that access point has the best connection, we're going to be using that access point. We also prioritize traffic. We know that if you're having a Teams call, that's the highest priority traffic, we're going to prioritize that over email, for example, right? And we do that dynamically, and IT can change the policies. There are different ways that you can do it. The second one is the Intel Connectivity Analytics. We actually place software in your device that we can send performance statistics and to either a service in the device or a telemetry service. So think about if I can send latency statistics, if I can send how many access points I have around me, what is the congestion of different channels, right? Which devices you're seeing. We can actually use that information to draw insights. And by using those insights, through the proper machine learning, we can actually develop models that we can then optimize the network performance. Okay, so this is the Intel Connectivity Analytics. We are working with several partners on this. There's a lot of excitement about all the data that we can provide and all the insights that we can get by using machine learning, and then optimize the network or the device or remediate problems. And then finally, Wi-Fi sensing, which it's going to be broadly available in Lunar Lake, and it's the ability to detect the presence of the human, right? It's called human presence detection. And you're going to see a demo of that today, and that's a third example of what we are actually bringing for the AI PC by using machine learning as part of Wi-Fi to make the platform aware of its vicinity. So really, what I want to show through these examples is that there's a powerful feedback loop between the AI PC and connectivity. Because actually, essentially what we're doing is we are using connectivity to create AI PC experiences. And then we are using what we have in the AI PC, things like the NPU, for example, to run some of these machine learning models that we need, and based on the data that we get from the connectivity, right? So there's this positive feedback loop between the two. So that's the key connection between the AI PC and connectivity. Okay, so let's deep dive now in Thunderbolt and all the capabilities that we are bringing to life in Thunderbolt in Lunar Lake. So with Lunar Lake, with support of Thunderbolt 4, it supports up to 3 Thunderbolt ports. Okay, what we are recommending to our OEMs is that Lunar Lake as a baseline, in every platform we have at least 2 Thunderbolt 4 ports, and the idea is that you can use one of those Thunderbolt 4 ports to connect monitors, and another port to connect, say, an external graphics card. Okay, if you're playing a game and so on. I mentioned also about Thunderbolt 5 that Intel has launched. You can use, think about it. You can use Lunar Lake with Thunderbolt 4, connect to a Thunderbolt 5 SSD, and still get up to 25% faster speeds with that Thunderbolt 5 SSDs. Okay, so that's something we do in the SoC to actually use an extra PCI lane, to be able to get those additional data rate, even though the platform actually supports Thunderbolt 4. And then we have Thunderbolt Share, right? And we're gonna talk more about Thunderbolt Share later. That's something new we have in Lunar Lake. So I'm gonna hold that until in a few slides we're gonna see that further. Now, I did say in the previous slide that we are recommending 2 Thunderbolt 4s as a baseline in every Lunar Lake design. What we also recommend is that OEMs place these ports in, each on one side of the laptop. And it's a better design, we think. And again, we can connect all these 3 monitors in one port with accessories, and then have this external graphics card on the other one. We also recommend to the OEMs that they clearly mark Thunderbolt ports. And the reason is, sometimes users get confused. Is it a USB-C port or is it a Thunderbolt port? So we are recommending to our platform OEMs that they clearly mark those ports so that it's clear what it is. Now, I want to circle back to Thunderbolt Share because I talked about it, but I said, hey, we're going to get back to it later. This was a software that we launched less than 2 weeks ago. Under the hood, a Thunderbolt Share is actually based on the Thunderbolt networking. Essentially it runs over Ethernet with an IP on top. And it's all about connecting PCs, right? So if you have 2 PCs with Thunderbolt, you can connect them with a single cable and then be able to exchange files, share screens, share resources between 2 PCs, okay? It's literally the fastest way to connect 2 PCs through a single Thunderbolt cable. And it works on Windows, Windows and both with Thunderbolt 4 and 5. So instead of just talking to you about Thunderbolt Share, let's go ahead and see a demo. I wanted to invite Rex from our team to show us a demo of Thunderbolt Share. Rex?
Thanks, Carlos. I'm Rex. Let me demo the Thunderbolt Share application to all of you. So yeah, before you want to use this software, of course, you need to install the software on both PCs. Okay, so and then you need to connect the Thunderbolt cable through the Thunderbolt ports. Let me do it. And after connection, you will see a main menu here. So this is the main menu for Thunderbolt Share. So think about those are 2 PCs. So this one is you can image, or can image. This is kind of desktop. So desktop used to have a big monitor like this one. I connect to the TV. That's my external monitor. Yeah, usually you will do your job, play the game on your desktop with the external monitor. And lots of you have the multiple PC. What you can do with this software? So first of thing, you can connect to your second PC. This is my second PC. You can see the screen there. So what I can do? The first thing I can do is I can play the video through the Thunderbolt Share software. You can see the quality. This is 4K, 6 frame, the video file. You can see it's really smooth. And the second thing I just mentioned, so we can use the same keyboard, mouse, and the monitor. It's likely the software KVM. So I can use my main PC and the type hello here. So you can see it is very smooth and then very low latency. What else? What else you can do? So I believe people would like to do the file transfer between 2 PCs. So in the main menu, there's another icon you can see. You can click. Now here's another menu. You can see the upside is the file is in my the master host, and in the bottom side is another PC. So I can transfer file between 2 PCs very easy, and with very high performance. For example, here is the 1 gigabyte the file. So if I want to transfer the file, it will only take a few seconds. So it's very quick. If you want to transfer a very big file, for example, this is 10 gigabyte, the file, it only takes around 20 seconds. So because Thunderbolt Share is based on Thunderbolt networking protocol, it supports 20 gigabit bandwidth. So that's why you have such high performance. And the last thing I want to show you is, I know lots of people care about so-called security. So with very high bandwidth, the data transmission, how about security? So don't forget, the most easy way is when you leave the PC, you need to log out your account or lock your screen. Let me do this way. This is my remote PC. I would like to lock the screen. sorry, I should show this one. Okay, so you are no longer to access the data. Okay, and sorry, do this way. Yeah, okay. And even you want to transfer the file, let's do this way. So transfer file, you will say, the screen is locked, so you cannot do anything. So that's the way to protect the data. So, okay, it's a very simple demo. I believe this is very easy to understand. And if you are interested, welcome to the showcase area. I will be there. Thank you.
Great. Thank you very much, Rex. Appreciate it. So yeah, so this is a great tool. By the way, it's in the showcase area upstairs. You know, Rex is going to be there, so feel free to stop by. All right, so let's change gears now and talk about wireless in Lunar Lake. Okay, so you know, at Intel we have a very successful history of integrating wireless into the SoC. We've done that twice, and with Lunar Lake we'll bring our third generation of integrated solution into the platform, and that's what we call the CNVI, right? I for integrated module into the SoC. And in this generation, and we have many firsts, this is going to be the first time that we're going to take Wi-Fi Sense broadly across every Lunar Lake platform, okay? We're going to have later a demo of Wi-Fi Sensing. You're going to see what it is. So, you know, hold your thoughts for a little bit, but essentially it's the ability to detect human presence around the laptop. It's also going to be the first time that we're going to have Bluetooth over PCIe. Now, why that is important is because over PCIe, we can have a 55% reduction in the boot time and also the latency in bringing the Bluetooth stack from sleep state. That gives us a lot of benefits by doing that over PCIe. And of course, because the wireless is integrated, essentially we have a smaller RF module. Okay, and because the RF module is smaller, you know, it gives us higher yield, lower cost, better thermals. So integration only brings positives, you know, to the platform and in terms of cost, thermals, and everything else. Now, if you think about Meteor Lake, you know, our current generation of the Intel Core Ultra, you know, what you can actually, you know, buy today. If you wanted to have Wi-Fi 7 Bluetooth, you can get that through a discrete module. That's what we call the GAO Peak, the Intel B200. Right, and that's how it looks like, right? So you have the platform on the left side connected to a module, and that, you know, and that module is, of course, a discrete module. Now, you know, Lunar Lake is going to be the first platform, as I mentioned, that's going to have Wi-Fi 7, Bluetooth 5.4. So what we do is that we take the digital MAC and the memory, and we move that to the SoC, okay? Now, by basically breaking that module into two, we need to have an interface between the MAC and the PHY that's together with the RF. For that, we created a interface called STEP. It's a serial interface. And the reason we had to create it is because Wi-Fi 7 supports 5.8 gigabits per second. There was no interface available that would be able to offer that speed at the low power, okay? Because it has to be very low power in addition to being high data rate. And then, as I mentioned, we are scaling, you know, because we have an integrated solution, we are able to scale Wi-Fi sensing, which we are seeing 10 times growth, you know, gen over gen. And so that's how it looks like in Lunar Lake, okay? Now, if you see the Lunar Lake on the left side, that Wi-Fi and Bluetooth MAC, which is that, you know, digital portion and the memory, it's now into the SoC, in particular in the platform controller tile. That's where it's located. And then we have these module, which we call the CRF. You know, it's the firmware PIC 2, that essentially has you know, the RF and you know, the signal processing, you know, on the PHY. And then we have this STEP interface that's connecting these two at 11 gigabits per second and low power. Oh yeah, and I did forget to mention, right? Essentially, because we're doing integrated, it's a 28% smaller chipset on the RF, okay, compared to the current generation that is discrete. Now, you know, a lot of people don't realize that is not just about the wireless module having the best performance. If we don't optimize at the platform level, it doesn't matter. You can have the best performing wireless, but if you don't optimize, you're going to get this that I'm going to show you right now. Memories today, and this is just one example. When you got a memory, you put a memory that has a given clock in your platform. That clock generates noise, okay? Whether it's the fundamental noise in the frequency of the memory or whether that's the harmonics, okay? The first harmonic, second harmonic, and so on. Now, Wi-Fi operates in 2.4, 5, and 6 gigahertz band. In this example, okay, we had a memory that was generating noise on the 6 gigahertz band, which is the new band that Wi-Fi uses, that we have available in our Wi-Fi 7 products. We are essentially getting a 50% throughput reduction because the DDR noise that was getting into the radio, right, into the antenna of the Wi-Fi. It's a 50% throughput. That is an 8 dB noise level on the wireless module. So what we do, right, we actually have a communication between our memory module, a memory controller, and the Wi-Fi controller that, depending on which channel the Wi-Fi is using, we adjust the memory clock frequency. And we are essentially able, in this example, in the blue curve, you can see a blue and red curve on the right side. When we have it turning off with the RF mitigation scheme, it's the red. When you turn it on, it becomes the blue, because we essentially change the frequency of the memory. So we essentially recover all that throughput that is lost. And this is a big value that, advantage that we have at Intel, because we can actually do these platform level optimizations and not just looking at the module itself. Now, we're talking about Wi-Fi 7. And we cannot talk about Wi-Fi 7 if we don't talk about the main feature in Wi-Fi 7, which is multi-link operation. And that's the flagship feature. And what multi-link operation is that, today in your Wi-Fi, most likely in the Wi-Fi you're using because of the access points here, you're connected to a given channel, whether in 2.4, 5, or less like 6 gigahertz. But you're connected, and you're just connected to that channel all the time. You establish your credentials, your security context, your data context. If you want to move to another channel, you have to break this connection and reestablish everything in the other channel. So, imagine that you are roaming, you're walking with a device, or you're just trying to change channels because your channel is very noisy, there's a lot of things happening. Your connection, and at the same time you have a WebEx call or a Teams call, you're going to see a connection drop because you have to disconnect and reconnect. What multi-link operation does is that it makes that completely seamless. You don't see anything anymore, right? All the bands in the access point, all the channels that access point has operational, you can move from one to the other, and your application is going to see no difference. You don't have to reestablish context for security. You don't have to reestablish context for data transfer. Now, it's really powerful because you can use that to increase reliability, throughput, reduce latency, and do what we call traffic separation differentiation. So let me show you so that you have an idea of how we can actually do that. Now, because I can use this multi-link now, essentially I can communicate with the access point over multiple channels, over multiple links, I can actually send the same packet. If it's a really important packet, I can duplicate the packet over multiple links. By doing that, well, if one packet gets dropped because of interference, most likely I can get the packet on another link. I can also send different packets across different links. And by doing so, I can increase the aggregate throughput, because now you're going to have higher throughput because you have multiple packets being sent. You can reduce latency because you can essentially balance the load. If you have multiple devices, the access point has, say, 10 devices, it can then say, hey, these 3 devices go to this channel, these 4 devices go to that channel, right? You can balance in the load based on the traffic. And once you balance the load, you're essentially reducing the latency for everybody. You can also do traffic separation or differentiation, meaning the access point can say, well, If it's a Teams call, it's really important, I'm going to put it on the best channel. If you're doing emails, I'm going to put you on a different channel that maybe is not as good of a quality. So there's so many degrees of freedom now that this multi-link operation brings to the platform. Now, the point is that not every multi-link operation implementation that you see in the market is created the same. Intel's implementation of the multi-link operation is called eMLSR, Enhanced Multi-Link Single Radio Operation. I'm going to show you what it does here. And in every platform that we have 2 antennas. In a traditional single radio, right? Say a traditional single radio device with a multi-link, what's going to do is that it's going to tune both of its antennas like you see in the figure on the top. It's going to tune to a channel and leave it tuned to that channel all the time. Even if the access point can support multiple channels, which is always the case, right? 2.4, 5, 6 gigahertz, the client is going to be looking at one channel. What we do with eMLSR is that because we have 2 antennas, we tune one antenna to one channel of the access point and the other one to a different channel. That's what you see at the bottom. The reason we do that now is because, well, you see all the channels are busy in this example, right? Now, if the channel goes idle, if one of the channels, the one at the bottom, goes idle, the device on the top, because it's just looking at one channel, is not going to be able to transmit and receive because the channel is busy. That's the regular multi-link operation, if you use single radio, that's how they're going to do it. What we do, on the other hand, is because we have our other antenna, that's listening and say, hey, that became idle now, I can actually go and transmit on that channel to the access point. Okay? So by doing so, we're going to essentially try to get the best of both worlds, meaning the lower cost and the lower power of single radio, but getting to a performance level of a dual radio. And we're going to get that in a little bit. Right? So once you do that, then you can then exchange data on the channel that is idle, in that case. Now, there are solutions in the market that support dual radios. Right? There are other products in the market that support dual radio. Because we use a single radio, we're going to achieve better. We're going to be better in terms of cost because a single radio is going to be lower cost. It's going to be lower power consumption because, again, it's a single radio. Now, you maybe ask yourself now, hey, what about throughput and latency? And the answer will be depends. Right? If a dual radio is listening to 2 channels, and we also have 2 antennas, right, in two channels as well. But if those channels are congested, there's a lot of stuff happening. It doesn't matter if you have a dual radio. You're just not going to be able to send data anyways. Dual radio is only going to be better if the channels are really lightly loaded. And then you can then access the channel more often compared to a single radio, to an eMLSR device. Now, instead of just telling you about it, I actually want to show you some data. Intel and Meta, we've gotten together for a while now. We did a lot of testing on PC VR, essentially getting your PC to render graphics that are going to show on your HMD. If you see this data here, the bar in the middle is dual radio. The bar on the right side is the eMLSR. The difference in terms of latency between a dual radio and an eMLSR, it's only about 3% when you have no channel contention, meaning there's nothing else happening in the channel. And that's the P95 latency, okay? If you look at the CDF, the 95% point. Now, if you have 70% interference, the difference is 5%. So really, the performance difference between a single radio and dual radio is very insignificant. And that's because, again, of the implementation that we have available in our platforms, this eMLSR implementation. So now, let's again shift the gears and now talk about the last piece of the puzzle, which is the software. So what are we bringing in terms of new capabilities in software in Lunar Lake? And that's, in addition to what we talked about, Thunderbolt Share, which is for Thunderbolt, we also have Unison. Right? And if you know about Unison, it's essentially a software that it's all about multi-device experiences, right? If you see the figures on the bottom, those are all the use cases that you have from Unison at the bottom today. You can, in your PC, be receiving text messages, sending text messages. You can be receiving calls on your PC. And that Unison app that you have on your PC or on your phone allows you to essentially have a seamless operation between your PC and your phone. With Lunar Lake, we're going to be launching tablet control. Now you can use your tablet, and you can use the peripherals in your PC to control the tablet. You can use the tablet as a second screen, okay? So if you're traveling, you have your tablet, your PC, you can just put them side by side. Using Unison, you can duplicate your screen. And then right post the Lunar Lake launch, we're also going to be launching what we call Universal Hotspot. If you are indoors, most likely you're going to have Wi-Fi. But if you're in a place that you don't have Wi-Fi for whatever reasons, with Unison now, you're going to be able to tether your phone to your laptop without you even knowing it. Right? If you bring your laptop and your phone, you're using your laptop, Unison is going to connect and make use of your cellular connection for you to get internet access on your PC. If, of course, you don't have a Wi-Fi available. So that's another feature that we're going to bring post Lunar Lake. And then finally, Swift Connect. So everything that I'm saying is that you require Unison on both on the PC side and the phone side. With Swift Connect, we can actually exchange files even if you don't have Unison on the phone. Okay? Even if you just have it on the PC, with Swift Connect, we can still exchange data between the phone and the PC. Okay, let me go back. So, all right, so with that, we're going to show you a demo right now of, Unison together with AR, VR, and Wi-Fi sensing. And for that, I want to ask my friend Leo here to give us the demo.
Right. Hello, Carlos. Today, we're going to highlight a few of the cool Lunar Lake wireless features. So Lunar Lake now will support the ability to use the same integrated Wi-Fi 7 networking card to also sense the user's human presence. So for instance, if the user approaches the system, it helps automatically wake the system. Same if the user walks away from the system, it locks the system and puts it to sleep. So this provided the added convenience, security, and power saving to the end users. So now I'm going to walk towards my Lunar Lake system right now. So as you can see, this screen got waked, so it detects my presence over here. And we have been working really closely with our friends at Meta to enable the wireless PC VR experiences for mainstream platforms. So now I will try to connect my VR headset, and then I will be projecting my virtual desktop to the large monitor over here. And it should be displaying shortly.
Yeah, we can see it.
Excellent, thank you.
All right, you can see it on the big screen.
Right, and then we also have the Workroom application. So this Workroom application, what it does is it provides additional virtual monitors, without having the additional actual monitors. So it's pretty useful for our daily usages. All right, so now.
So we can essentially have 3 monitors, right, when you're looking at your HMD.
Correct. And so now you will able to see all the applications like my desktop over here. And I'm going to play a really short video from our friends at Meta.
Hi there, I'm George Twickwich. I'm Senior Director and Head of Wireless at Meta Labs. We are very excited here at Meta to continue our collaboration with Intel on enabling great wireless PC VR experiences, not only for gaming, but also for productivity use cases and remote desktop mode. Looking forward, we strongly believe that our joint efforts will help scale and expand wireless PC VR experiences to a broader set of mainstream users and help transform their day-to-day interactions with PCs. Thank you.
All right, thank you from our friends at Meta. And so now also on this Lunar Lake system, we have the ICPS. Okay. So as you can already feel it, that the overall experience is pretty smooth and immersive. It's all thanks to the Intel connectivity performance suite that it helps to tag and prioritize the wireless PC VR traffic.
And so, Leo, just a question. This is the HMD connected with Wi-Fi, and you're actually using your peripherals. And the peripherals are controlling the HMD. You're getting that rendered, right? So everything using a single radio, right?
Correct. That is correct, Carlos. Okay. All right. And next on this Lunar Lake system, we also have the Intel Unison. So this is a really powerful phone to PC application. So as a short demo, I'm gonna use my cell phone. This also has the Intel Unison application on it. So let's say, let me take a selfie with all of you guys in the room real quick, and then, so what will happen is the photo is actually transferred immediately to my Lunar Lake system.
Yeah, we can see it right there.
Yep. So you got the photo. Once I took the photo, it's actually instantly on my phone, on my PC right now.
And this is using Unison.
Correct. That's the Unison application.
Yep.
All right, and that will be all for my demo today, and I hope you guys enjoyed it. Thank you.
Thank you very much, Leo. Yeah, this is a great example of what you saw in this demo was Wi-Fi sensing, single radio connected between the HMD and the platform, Unison, or everything in a single demo. Okay, this really showed, and with ICPS too, that it's prioritizing the traffic between the HMD and the PC. So even if the PC was doing some emails, the ICPS will prioritize a connection with your HMD to make sure that that's completely seamless. Right? So it's multiple applications in this demo. So you can see all that coming together. All right, so with that, let me then conclude. And everything that I've talked about so far was about what is available in Lunar Lake, meaning about the present. I want to just, in one slide, tell you about how we see connectivity evolving in the future. And with the advancement of the AI PC, we see a lot of opportunities for essentially changing the way people experience the PC in the future. Wi-Fi sensing, which when Leo came next to the PC, just woke up the PC, is just a baby step. Imagine that we can also use the Wi-Fi or your wireless connectivity to detect gestures, to detect, if you are moving your hand in one direction, another direction, if you are making gestures with your fingers so that your platform can then react according to the gestures you're making. Imagine if you can use the wireless to tell, if you are bringing close to a monitor, is the monitor, what is the closest monitor to you, right? If you have multiple monitors, because I wanted a pair, I wanted my screen to show, to the closest monitor. What if I could say how many monitors so that if I want to duplicate, I know which one is right, which one is left? There are so many use cases that we can enable now that we have the capability to use wireless together with the AI PC features, and then start creating new experiences that are going to make the PC context-aware and intelligent. So that's really where we see. It's taking connectivity above just as a data pipe, but as a sensor that we're going to use, of course, for data, but also to create new experiences that are really going to change the way people use the PC today. So thank you very much. That concludes my talk, and I think we'll go into questions.